Hello everyone, and welcome to my channel and one of my Fundamentals Explained video. In this one we're going to be discussing what is the double spending problem. So in the real world, when you buy something with a note or a coin, you cannot double spend it. In other words, you cannot use the same coin to buy two different things. So let's say you go to the supermarket and you use $1 to buy bananas. You cannot use this same dollar to buy apples because the dollar was already spent. However, in cryptocurrencies, it's not as simple as it is in the real world. So we're gonna have a look at this double spending problem and solutions to solve it. So let's say we have Mallory. Mallory is a malicious actor in these lessons. So Mallory sends Alice 1 Bitcoin, and then he sends the same Bitcoin to Bob. So this might sound impossible, but it is in fact possible. And there are at least 5 ways of accomplishing this kind of attacks. One of the most common ways of accomplishing this attack is through the 51% attack. In this kind of attack, basically you have miners that have more than half of the computing power of the whole network. So they are able to fork the network and make their own network or their own blockchain the honest one by creating blocks at a faster rate. So we have the normal blockchain being built here on the left. And then once the fork happens, this normal blockchain continues growing. But because this attacker, let's call him Mallory, has more hashing power, he can mine more blocks, therefore making his blockchain bigger than the original blockchain. So as you can see here, our honest one has 3 blocks, whereas Mallory has already 5. So then this becomes the actual blockchain, the blockchain that people are gonna be adding blocks to. Another way to accomplish this is through one thing called the race attack. So the race attack, it's when 2 transactions occur very quickly, one after the other, and they are added to the blockchain. So one transaction could be a payment, for example, to a merchant. So this merchant here receives this transaction, and if he accepts unconfirmed transactions, then he's gonna send the goods back to Mallory. Let's call him Mallory, he's our malicious actor. But the merchant does not know that Mallory sent the same cryptocurrencies to himself, for example. And then this transaction is the one that's going to be added to the blockchain. This is going to be added here at the end. So when the merchant sends the goods, the malicious attacker adds his transaction that sends the coins back to himself to the blockchain, and therefore invalidating this transaction to the merchant. So he already got the goods, but the merchant did not get paid. So another way to achieve this double spending attack is through the Feeny Attack. So you probably know that Hal Finney was the first recipient of a Bitcoin payment. So he, and some people believe that he is actually Satoshi Nakamoto. So he suggested the Finney attack in a blog post in the Bitcoin Talk forum. So the way the Finney attack works is as follows. So let's suppose the attacker is generating blocks normally. And then in each block he creates a transaction, let's say from A to B, which are addresses that the attacker controls. But to cheat the merchant, whenever he generates a block, he does not broadcast it to the network. Instead, he uses this A to make payments to the merchant. So he pays the merchants with the cryptocurrencies stored on A, and then the merchant sends the goods back to the attacker, Mallory. And then, once he receives the goods, then he broadcasts the transaction. And this transaction will take precedence over these transactions here that were sent to the merchant. Then we have the vector 76 attack. This is basically a combination of the race attack and the Feeny attack. And this is also known as the one confirmation attack, because he waits for one confirmation to happen and then the attack proceeds. And finally we have the alternative transaction attack. So we have the blockchain, and then Mallory submits a transaction and pays a merchant. But then privately he forks the blockchain and he adds a transaction that sends coins back to himself, or has a fraudulent double spending transaction. And after waiting for n confirmations, the merchant sends the goods to Mallory. So Mallory gets the goods. But then if it happens that the attacker found more blocks, more than n blocks, during the time that it took the merchant to send the goods, then he broadcasts these transactions to the blockchain and invalidates the previous transaction. Or not the previous transaction, but the transaction to the merchant becomes invalidated. So in order for this to work, the attackers need to have huge amounts of computing power. In the case of the Bitcoin network at the moment, whereas there's huge amounts of computing power worldwide. So in order to perform this attack on Bitcoin right now is extremely difficult, but it is a problem that is there, the 51% attack or the double spending problem. So in a very brief way, this is basically the double spending problem. So spending the same cryptocurrency twice. And as we've discussed in this video, there's a few ways to perform this attack. Although today this is not really doable, and there are a few examples of actual real world attacks, and they happened a few years ago. But nevertheless, it is good that you are aware of this problem, of the double spending problem, because it really is a fundamental problem of cryptocurrencies. Let me know if you have any questions in the comments. Like or dislike this video. If you didn't understand, please let me know. If you want me to go into a bit more detail into each of these attacks, also let me know. If you're not subscribed, please do so. And as always, thank you for watching, and I'll see you next time.